on. So let's say I have something like this. 4 and 2 over 7 minus 2 and 5 over 7. If I go ahead and isolate those whole numbers, I'm left with the fractions. So again, they've got the same denominator, so that's good, apples to apples. But I can't take 5 away from 2. So I'm going to show you 2 ways to do this one here. Remember, if you look over to the left here, actually I'm going to go back one, right? When we said that, is it this one? Oh, sorry guys, I think it's this one over here. Hang on a sec, I lost my way. Ah, there it is. So this one here, when we say that mixed fractions or improper fractions, they are, so a whole is a whole, sorry, a mixed is a whole and a part. It could also be, right, when we write them as these impropers. But I want you guys to remember, if I go back to this here, remember when we talked about a whole being equal to the numerator and denominator being the same, right? So if you look over here, I have a whole shape, but I've cut it into 2 pieces. But I've shaded in both sides, meaning I've given away both of those halves. So 2 over 2 is still a whole for that shape. Same thing over here. Even though I've cut my shape into 4 pieces, if I give away all 4 pieces, I've given 4 of 4 away. All right? So that being said, I can't do this one quite simply as just going like this. What I'm going to do is I am going to take this 4, I am going to cross it out. So it's going to make that whole number now 3. But essentially what I'm going to do is turn that one whole that I'm borrowing essentially into this. Because see the 7, our shape is cut into 7 pieces, right? So essentially what I'm doing now is 7 over 7 plus 2 over 7. So essentially I'm left with 9 over 7, right? So let me write that out a little clearer here. 3 and 9 over 7. Does that make sense? It's still the same, right? I've got a whole and a mix. If I was to transfer this back, do you remember, it's kind of like these things over here, right? We ended up with this, then we turned that improper into that mix, but then added it back into the equation over here. So I'll show you again in reverse for this one. If I was to take this mixed fraction, right, I've got a whole, but I've got an improper. So again, it's essentially saying this. My 3 wholes, right, and then I'm going to turn that improper back into a mixed, plus, because again, remember, 7 will go into 9 one whole time, right? 9 minus 7, we're left with 2 over 7, right? And if I add those back together, I end up with my 4 and 2 over 7 like I had up here. Is this making sense at all? Sort of, kind of. Let me turn the page and start that one off clean. So again, this was the one that we were working with. Minus 2 and 5 over 7. All right. So, once again, I'm going to essentially cross this 4 out, and I'm going to then say 3 Would it make sense to you guys if I did this? Plus 7 over 7 plus 2 over 7. Does that kind of make sense? And it's just dealing with, let's pretend that 2 and 5 isn't there yet. We're just trying to turn this into something that we can use here. Right? So there's my whole number. Right? This is just going back to the adding that we did earlier. Right? Isolate that whole number. So I'm just left with the 7 plus 2. Right? So again, apples to apples. Sorry. Okay, so this one here, just the fractions. 7 sevens plus 2 7 equals our 9 over 7. Bring that whole number back into play, right? And we get the 3 and 9 sevens. Does that make sense? So now I can take that 3 and 9 sevens, so I have a mixed number but with an improper in it. But now I can do this equation. Because now when I isolate the two wholes, right, again, I'm now left with a set of fractions that I can easily navigate. Right? So let's do that. So I'm going to do my 3 minus 2, and we are left with 1 whole for now. Again, I'm just going to put it in this little blue room all by itself for a moment while we deal with now the leftover fractions. So now I have 9 over 7 minus 5 over 7. Apples to apples. I can take 5 away from 9 now, and I'm left with 4 over 7. Right? Then I just bring that and incorporate it back into the 1. Okay? Or bring the 1 down here, either way. So let's say that. 4 over 7 plus the 1, left with 4 over 7. Did I lose anybody? Is anybody's brains exploding? All right. So that's borrowing from the whole number. Okay, borrowing from the whole number. However, there is another way that we can do this. Instead of borrowing from the whole number, we could also just turn these into improper fractions. Right? Hang on, I have my stuff in front of me. So again, let's start off with it clean. 4, 2 over 7 minus 2, and 5 over 7. So instead, this time we're going to turn them into improper fractions. And remember how that goes. Whole number times the denominator plus the numerator, right? And we end up getting 30 over 7. Okay? Same thing over here. I'm going to multiply the whole by the denominator and add the top. Right? So 2 times 7, then add the 5 to get 19 over 7. So now I've turned it into something that I can easily take away, right? My bigger number is over here. So then I'm left with 11 over 7. Again, improper fraction. So again, it's like 11 divided by 7. 7 goes into 11 once, right? With a remainder of 4 over 7. So whichever way that you find easier. Okay. Did I lose anybody? Is everybody feeling okay with that one? Yeah? Okay, good. Jay, you're doing okay over there too, bud? Good stuff. Kenny, I see you. Good. Okay. I want you to try this one. I think that's the one. Yep. Okay. So let me take a little snapshot first of this. Maybe that one's going to help you. Okay. Put that up on the side there. Just to kind of give you a hand. And the next one I want you to do, I want you to try this. 12 and 3/8 minus 5 and 5/8. All right. Give that one a shot. What would you do with that to turn it into something that we can equate? What would be equal to saying 1 whole in this case? Yes, Ahmed. Alrighty, so for this one, again, remember this 1 whole, I'm going to look at what my denominator is on my fraction. My shape or object is going to be cut in 8 pieces. So I'm going to turn this whole into a fraction version of it, which would be, right, like writing it like this. 8/8. Remember, that's the same as a whole. I'm using this denominator as my guide. So 8/8 is the same as a whole, or 1. Right? And now it's just 8 minus 5 is our 3. Keep our denominator the same. All right? Ahmed, did anybody else get that? Or did anybody just explode? Did that make sense at all? Essentially, we're trying to turn this into something that correlates or is related to this fraction. Right now, they're not related. They aren't really talking to each other very well. The communication isn't there. So we have to put it into the same language. And that's kind of what I've done down here. I've translated this whole number into this fraction's language. All right? And then went from there. Again, guys, this is recorded, and I shall send that to you if you so desire. I'll just send it as a mass email to the group.